Class, and welcome to lesson 3.6, the zeros of the quadratic function. Just remember, ladies and gentlemen, that the zeros are the same as your x-intercepts, same as your roots, and same as your solutions. So today we're going to be focusing on the number of zeros, not specifically where the zeros are at on the x-axis, okay? So just remember, folks, for a quadratic function, you can have either 0 zeros or 0 roots, or 1 0 or 2 zeros. Let's graphically show how that appears. If we want no zeros, how do we draw our parabola? Well, first of all, if we have a parabola and a vertex is above the x-axis, if it opens up, it will never cross the x-axis, so that shows you that there's no zeros. Another option is, ladies and gentlemen, is if you have the vertex below the x-axis and it opens down. That will again give you no zeros. All right. The next thing we want to make sure we know is that we're looking at a solution where we have 1 0. To have 1 0, that means it only hits the axis once. The only case that can be is if the vertex is on the axis. So again, as long as the vertex is in the axis, it could open up or down. Doesn't really matter. But we're going to write that the vertex is on the axis. All right. And the last case, ladies and gentlemen, when we have 2 zeros, is what's the more common case, ladies and gentlemen, where our vertex is below the x-axis and it opens up, so it hits the x-axis at 2 spots, or the vertex is above the x-axis and it opens down. All right, let's quickly examine and compare it to what happens when we are taking a look at the quadratic formula. There have been cases where we couldn't answer the quadratic formula, which means there was no answer. And just remember, under the square root sign, it was negative. Okay? When we had 1 root, that would mean when you're using the quadratic formula, there was a 0 value. And when we had a positive value in the square root, anything positive, like between 1 and infinity, then you have 2 different possible ways where it crosses the x-axis, or 2 zeros. All right, there are different ways to determine the number of zeros, and that depends on what your equation is given as. For example A, folks, please notice that this is given in vertex form. And if it's given in vertex form, we can just quickly visualize, hey, what's our vertex? Our vertex is 1 and -2. So we plot our vertex, which is 1 and -2, kind of down here. And then we go to look at our direction of opening, and that's based on A. So if A equals 4, that means it opens up. So if I try to open my parabola up, this will show us that, hey, indeed we have 1, 2 zeros. And again, if you have vertex form, quickly look at the vertex and compare the direction of opening. The other option, ladies and gentlemen, is if you were given factored form. If you were given factored form, you would automatically see if there was 1 or 2 factors by the expression given. The third, and I would say the hardest one, is if you're given standard form. Okay? So if you're given standard form, the only 2 ways you could find out how to solve the answers or to get the zeros would be either to factor if it's easy. But if it's not easy, then you're going to use quad formula. All right. So taking a look, in order to find the zeros, we know that the function has to equal 0. Okay. And we can look to make this question easier by dividing every term by 4. So divide by 4. Okay, so we're left with 0 equals x squared minus 6x plus 9. And looking at this expression, we could factor. So I'll show you 2 cases here. So if we factor, ladies and gentlemen, we're going to let 0 equals, and again, you might want to do your product equals 9, your sum equals -6. What two numbers give you that? -3 times -3. Aha, what do you notice here, ladies and gentlemen? You notice that they're the same factor. What does that tell us? That tells us that when we go to solve this, we're only going to have one solution. And when we have one solution, what does that mean? We're going to have one root, or 1, 0. Okay? You may also have recognized this as a perfect square. And it's a perfect square in both cases, and if you had recognized that, then you could also say that, hey, this means therefore we have one solution, or 1, 0. Okay? How does that look like instead of if we didn't factor, if we use that same expression and we did quadratic formula? So again, A equals 1, B equals -6, and C equals 9. Plug it into your formula, and you should have 6 plus or minus the square root of -6 squared minus 4 times A, which is 1, times C, which is 9, all divided by 2 times 1. Simplify that expression. You're going to have 6 plus or minus, and if you simplify inside the bracket, you're going to have the square root of 0 divided by 2. Whenever you have the square root of 0, that means 0, which means really, ladies and gentlemen, the plus or minus cancels. So in this case, we're only left with x equals 6 divided by 2. When you simplify that, x equals 3. So therefore, 1, 0, or one solution, or one root. What does that mean? Therefore, in this case, the vertex is at the axis. So it's on the x-axis. Okay? Now, notice, ladies and gentlemen, the connection when you do the quadratic formula in here, that it's 0. The square root of 0 is going to give you one root. If it's negative, we've learned before that it gives you no roots or no solutions. And if it's positive value, then we know we're going to have 2 roots. But it doesn't really matter what the rest of the quadratic formula does in order to determine the number of roots. So we're going to take that part, which is the b squared minus 4ac, and we're going to just use that to determine in standard form when we have 0 roots, 1 root, or 2 root. So let's go to the next page and we'll break that into its spots. Okay? So the zeros can always be found by either factoring or using the quadratic formula. However, I was just talking, ladies and gentlemen, about how if we're finding the number of roots, we can just use that thing called the discriminant, and that's the value that's underneath the square root sign. So this is a new piece of terminology for you. So b squared minus 4ac is called the discriminant. And we can use that to tell us how many roots, not where the roots are, but how many. And all we need to do is realize about our square root symbols. So when b squared minus 4ac is greater than 0, there are 2 roots. Okay, when b squared minus 4ac is equal to 0, there is 1 root, just like the last example we did. My fault. Let me erase that. There is 1 root. Okay, and the last example, ladies and gentlemen, b squared minus 4ac, it's going to be less than 0. There are no roots. Okay, because it's negative, right? So it's the negative part. So it's really negative under that square root sign. All right, let's use this discriminant. And again, the discriminant is only used when you're given standard form to determine the number of roots. All right, example 2a. says use the discriminant to determine the number of real roots. Please be careful with your wording, because on your test sometimes I'll ask you for the roots or the number of roots. Okay, so what we're going to do is write down our discriminant. So b squared minus 4ac. And how do we sub that information in? It's the same as how you do it for the quadratic formula. So a equals 7, b equals 3, and c equals 1. So sub that information in. And what do we notice here? We have b is 3 squared minus 4 times a, which is 7, times c, which is 1. Use our calculators or our brains, and we're going to have 9 minus 28. And 9 minus 28 is negative 9. Look at the value, negative 19. This value is negative, therefore there are no roots. Because D for discriminant is less than 0. Okay, try the second one on yourself. Please pause the video, give it a try, and then come back and we'll see if we can do the answer together. Okay, pause. Okay, now hopefully you're back with me. You've tried it yourself. So again, we use our discriminant. We sub our values in. Negative 22 squared minus 4 times 10 times negative 2. Use your calculator and you've got 564. Therefore, there are 2 roots because D is greater than 0. Now, some of you may have said, hey, Mrs. R, do we need to factor because we could divide everything by 2 in this case? It's not necessary because it's still going to give you an answer that is greater than 0. So if you happen to have divided every term by 2, that will affect your answer. And I'm not worried about that in this case because it's just asking for the number of roots. All right. Now we're going to make it a little harder. Are you ready? Here we go. This question's different than that one. So it says, for what values of k, which we're introducing just a new variable that we're going to find, will be the function f at x, 5x squared minus 6x plus k have 2 x-intercepts. So as soon as we know we have 2 intercepts, that means we can use our discriminant. So we take our discriminant, and what do we put down? If it's got 2 intercepts, you go back up here, it means it must be greater than 0. So we're going to make it greater than 0. Now we're going to solve this inequality by subbing information in, and then I'm going to, over here on the side margin, I'm going to write a little summary or a little note on inequalities to help you. So you want to just set some space aside for a summary after, okay? So let's sub our values in. And in this case, don't get confused here. A equals 5, B equals negative 6, and C actually equals K. All right, so let's sub it in here, folks. So we've got negative 6 squared minus 4 times 5 times K is greater than 0. All right, so negative 6 squared is 36 minus 20K is greater than 0. We want to get this negative 20K by itself, so you take this positive 36, bring it over, becomes negative 36. And now is the important part of inequalities. This is where it's different than when you solve equations. Whenever you divide or multiply by a negative value, like we're doing in this case, we must switch the sign. Okay, so right now it's a greater than sign. We're going to change it to a less than sign. Okay, so K is going to be less than 36 divided by 20, because the negative divided by negative is a positive. Okay, you could reduce that down or put down K has got to be greater than 1.8. Okay, so the important thing I want to write down here about what's an inequality. Inequality is like an equation, but instead of having an equal sign, you have either a greater than or less than equal to sign. Okay, so let's just write a little summary in here so we can remember this. An inequality is solved the same way as an equation. Except when multiplying or dividing by a negative value. Just like this example here. Okay, so what we need to do is therefore we flip or switch the inequality. Okay, so if it was negative or it was greater than to begin with, it becomes greater or less than, and if it was less than, it becomes greater than. And again, that's when you are dividing it by or multiplying it by a negative value. All right. We're going to be dealing a little bit more with some harder examples with these variables k in our last example. Let's flip it over. Okay, example 4. The graph of f at x equals x squared minus kx plus k plus 5 touches the x-axis at one point. What are the possible values of k? So the first thing that's important to realize is that we don't have k in one spot, we got k in two spots. Okay, let's just start with making a look at our discriminant. It says that it touches the x-axis at one point. So what does that mean? We set our discriminant equal to b squared minus 4ac has to, because it's got 1 point, has to equal 0. Now the hard part maybe here is deciding what a, b, and c are, because we've got 4 terms. But just follow your standard form. A equals whatever's in front of x squared, so that's 1. B equals whatever's in front of x itself, which is negative k. And c equals the constant, or the number without any x's. So we're going to actually say c equals k plus 5. All right, that's awesome, isn't it? Let's sub things in, and we can solve. So we're going to have negative k squared minus 4 times a times c equals 0. Remember, negative k times negative k is positive k squared minus, you got to use your distributive law here, so it's negative 4k minus 20, ladies and gentlemen, equals 0. And then we look to factor, so let's just spend a couple or a minute or two looking, see if we can factor, because that's easiest. So you need a product of negative 20 or a sum of negative 4. Is that possible, ladies and gentlemen? No. So we take a look at other alternatives. Does it look like a perfect square? No, because you can't take the square root of negative 20. So then we're going to use quadratic formula. Okay, to solve for k, it's going to be k equals 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 20, all divided by 2 times a, which is 1. Look to simplify here, gang. We've got 4 plus or minus the square root of 96 all over 2. Look to simplify our radical like we've done in the last couple classes. So over in the margin here, root 96 equals, what's the biggest root that can go in there? 16 times 6. So we're going to bring, just remember guys, we're going to bring the square root of 16 out. Square root of 16 is 4, and we're left with root 6. Okay, so let's plug that in here. So we have k equals 4 plus or minus 4 root 6 and divide by 2. Again, you might say, hey, Mrs. R, when do I know how to when do I simplify the radical? I always look to see, for example, my denominator is even, my b is even. So if I could somehow pull out an even value from my radical part that's entire, make it mixed and cancel. So for example, here I can cancel. 2 goes into 2 once, it goes into 4 twice, and into 4 twice. So what I'm left with is k equals 2 plus or minus 2 root 6. That's an awful lot easier to plug in your calculator, your two options. So k either equals 2 plus 2 root 6, or k equals 2 minus 2 root 6. All right, plug that in your calculator and you should have k equals approximately 6.9 or k equals approximately negative 2.9. All right. There ends this day's lesson. Ladies and gentlemen, you should be getting ready to get ready for a test. We have one more lesson and then a review day, and then get ready for your Unit 3 test. So practice. Any questions you need help with, please come see me. Here's tonight's homework, page 185, numbers 3AC, 4, 6 to 9, and give 13 a try as well. Have a great day, and again, come see me if you need some extra help.